All right, here's example 4. Part A, you have 71.5 milliliters of a 2.5 molar solution of Na2CrO4. You also have 125 milliliters of 2.5 molar solution of AgNO3. Calculate the concentration of Na plus after the two solutions are mixed together. Part B, when these react, a precipitate is observed. What is present in the solution after the reaction is complete? Note, the solid is not considered to be in solution. So for part B, we won't include the solid precipitate that's formed. We're just talking about what else is left in the solution. All right, let's walk through the solution for example 4, starting with part A, where we are asked to calculate the concentration of the Na plus ions after the two solutions are mixed together. So I've made a list of the given information. We're given 71.5 milliliters of 2.5 molar Na2CrO4, and I just grabbed that from the problem, right? And 125 milliliters of 2.50 molar silver nitrate. Okay. The next thing I'm going to do is write a balanced equation. So I'm combining this Na2CrO4 with AgNO3. My products are, now this is a precipitation double replacement reaction. So now we have sodium with nitrate, NaNO3, and silver with CrO4, so Ag2CrO4. You really have to remember these are ionic compounds, so we need to make sure we're balancing the charge as we go. So it's not AgCrO4, it's Ag2CrO4. Okay. Now this is insoluble, so it forms a solid precipitate, and of course sodium nitrate is aqueous in solution. And then the last thing I did was just make sure I balanced it. So 2 AgNO3 and 2 NaNO3 balances that reaction. Okay, the initial amount of sodium ions in the initial solution. So the initial solution is this Na2CrO4. Okay. So we're going to start with our concentration of our solution is 2.50 molar, right? Which is 2.50 moles per liter. Okay. Then we multiply that by the liters. So 71.5 milliliters is 0.0715 liters, okay? Now that gets us 2 moles, but this is moles of Na2CrO4. Why am I multiplying by 2 here? Because if you look at this formula, there's 2 moles of Na plus ions per mole of Na2CrO4. So we multiply by 2, and that gives us 0.3575 moles of Na plus ions, okay? Now, what is the concentration of those ions after, so we change colors to symbolize after the solutions are mixed together? Okay, so there are no more Na plus ions, right? This number of moles stays constant because the ions are spectators in the solution, right? So it's sodium is aqueous before and aqueous after. So the number of moles in the solution that we start with for sodium ions is the same as the number of moles after they combine together. So I've just taken this 0.3575 moles, and again, I'm trying to find the concentration, which is moles per liter. So I'm going to take my moles and divide by, now this liters is the total number of liters of the two solutions mixed together. So 0.0715 liters plus, of course, 125 in liters is 0.125. So I combine those two volumes and I get an Na plus concentration after the solutions are mixed together of 1.82 molar.